well, something dear to my heart, continuations. Done lots of stuff for me, but we'll hear what they've done for you.
Great. Yeah, so thank you very much. It's a pleasure to be here and present our paper, which is joint with Bogdan. He's the main developer on this project. I'm the main economist on this project because, of course, every project needs an economist. Don't worry, though, it's not contagious, so you should all be fine. So what this is about is continuations and our use of it. Our use of it in what? Well, we've been developing for a couple of years now Congame, which is a platform for economics experiments. And just to give you an idea of what that is, I'm going to show you a Hello World example just to fix ideas so that you don't think of experiments in the lab or anything like that. But the way you should think about economics experiments is surveys on steroids. So I'm just going to walk you through a very small one, just to highlight the features that the platform should make easy and what it ought to be doing. So here's a very short survey. I'm just going to type in my name, my favorite programming language. In case you're wondering what it's written in, it's in Racket, and that's my favorite one. So have you ever used continuations in an application outside of computer science? I'm not sure how many of you have done it. So we have, and you'll see it today. But my guess is most of you know, unless you're a compiler, implementer, probably. How many of you know the difference between regular and delimited continuations? All right, so I'm also going to tag yes. I wouldn't want to talk with both of you formally about this, though, but I kind of understand what it is. All right, so now the main thing I want to point out, just going to the next page, nothing earth-shattering at all, but obviously this page responds to what I've done. Let me make it bigger. So, you know, it has tracked my name. It has responded to the fact that I said Racket. It says its favorite programming language is Racket 2. So, in short, this is just very stateful applications is what we want to write on the web. That's the main thing that I would like you to take away, technically speaking, for economics experiments. And finally, just to give you an example, you know, there's going to be a lot of randomizing in economics experiments. Usually people get lotteries, they play games in the game theory sense with each other. And so here in the background, we tossed a coin. I'm going to have to guess. I'm going to guess heads. I always guess heads. Okay, and this time I won. Okay. All right, so this is essentially, it's a web interaction, but the main feature I want you to take away from this is that it's a very stateful web application. It's not just one page and another page. These things can go on for like 30 minutes. We might want to repeat them, and so on. All right, and so this is what Congame is supposed to and is helping with. But moreover, this was the Hello World example. What really the goal is of Congame is, because this could be done in anything, is to expand the range of the possible experiments. And what I have in mind here is to a large number of interacting participants, playing market games, essentially simulating market games by having many people interact, over long periods of time, repeatedly, every week, with many overlapping treatments. Treatment means essentially A/B test. It's kind of, I guess, what, you know, in computer science, it's the closest that you'd get to that. You can also think of treatments in medical experiments, except that economists don't do medical treatments. It might be personalized to each participant, and I might want to track multidimensional outcomes. The important thing about this is that this really, what this requires and why we started with this is because it requires strong composability and reusability features. Because I cannot build this up if every time I do this, I have to rebuild everything from scratch and copy-paste it, let's say. All right, so why custom platform? The example that I showed you might have made you think that obviously this is doable elsewhere. My claim from having used existing tools before is that most of them have very low composability and reusability. And essentially that comes down, it's not quite just that, but due to no or poor notion of what a study is, what therefore the fundamental building block is that we want to compose and reuse. So for instance, take web frameworks, Django, PHP, React, whatever your favorite framework would be. First, there's no notion of a study. So if I want to write it, I have to create this myself. This is going to be used by social scientists and economists. There's no, like, we don't like coding for coding's sake. This is not something we find fun. And all of these web frameworks expose a lot of web. Requests, responses, database. I have to understand and think about all of these. I don't want to do that. I don't care one bit about it. When I talk to a colleague of mine about an experiment, I don't say, and then we store this on the database, and then I have to think about transactions because otherwise we might overwrite it. Like, that's not how we talk. We just say what we want to happen. Qualtrics, some of you might have seen Qualtrics. The main problem is, and the benefit, is that it's a clicky GUI interface. It's extremely user-friendly for small and simple studies, and it's extremely tedious if you want to do something larger scale. It's essentially not, like most of these tools, no coding tools, composability and building up on each other is very, very hard. Again, therefore, it's going to be fantastic for small experiments and horrible for larger ones. Finally, O-tree, which none of you will have heard of, but that's like the main inspiration for Congame and the one that I used before. It was built on Django, so Python web framework. But again, the main problem there is that its notion of study is very bad, and I'll show you explicitly for O-tree the shortcomings in a little bit. Oh, by the way, I should have mentioned, which I am now, I haven't talked about continuations yet. So the first half of the talk I'm going to talk about what the software is trying to achieve, why we want to do something, and therefore how continuations gave us some benefits, but I'm not going to explain continuations. And then Bogdan takes over and explains specifically how the continuations fit into this and the problems we hit with them. All right, so as I mentioned, Racket is the programming language that we used here, and we are using its continuations quite heavily in the core of Congame. And I hope to be able to convince you of this, but the continuations enable multiple benefits. First, we can use the full power of Racket anywhere. The example will make a little bit clearer what that is, but hopefully it will be. And they allow us also to use a composable study, a notion of a study, what a study is. In particular, it's a recursive data structure consisting of a study, which is a sequence of steps, and each step is either a page or another study. And so, of course, that way it goes down, and you can see how you can then build larger studies from that. And finally, which people who have used continuations on the web may already know, so this is a standard benefit, you can write code in a direct style, which we'll illustrate later on, where I don't have to think about the request and response cycle. I don't have to think about, oh, here I'm sending it, here I'm receiving it, these two pieces need to be hooked together. Now, when I say here, by the way, continuations enable these benefits, I'm not saying they are necessary. I'm saying they provide these benefits. There would be other ways to do it. All right, I don't know how much, you're not going to see very much of this, unfortunately, I think. So probably if people in the back are not going to be able to read this. But let me just say, so this is O-tree code for the coin tossing example that I gave you. This is heavily edited. It's not the full code that you would need. There would be more. What I would like you to realize is there's one file called settings that has to be changed, one called choices, it's the init really, and one for the results. So there's 3 parts that you need to have. Moreover, since after I flip the coin, which is happening here in the random choice part, and I check whether the player chose the right thing, I have to store this in a global variable called player.participant.ok, which I have to essentially initiate. It's not quite an initiation, but in the settings file. In the settings file, I have to say, please make a field in the database called OK, which can be called via this mechanism. Why? This is so that these different apps, which is how O-tree thinks about studies, so that they can share this variable and therefore pass on the data from one to another. And if you can't share the data, well, then you can't compare, then you cannot make later stages depend on what I did before. Then I wouldn't be able to do that. So you already see here some bad features of it, which did get on my nerves when I was using O-tree, especially having a background in functional programming. First, the code is very non-local. You have to split it up across many files in a way that is kind of unnatural, in the sense of unnatural from the point of view of a study creator who thinks of it as, this is actually local information, I would like to deal with it here, but the software forces you to split it up. Secondly, I talked about the data, the global variables, when you want to share them. You essentially pollute always the global namespace. There's no way of not making it global once the variable has to be shared between apps. And of course, that leads to a lot of problems in reusability, because if there's 2 apps that call a variable OK to talk to each other, then you're going to overwrite that variable for one while the other one is unaware that you overwrote it. Right? So this is a standard problem with global namespaces. Finally, something that is not like obvious from the example I showed you, but if I wanted to have 2 coin tosses, but in different places, and I wanted to reuse that same app, the way I reuse it is as follows. Take the app, copy paste it, move it over, rename it choices 2, do some changes to it, now you can use it again. This is like the world's most horrible way of reusing. This is literally why I left O3, because I had an app called Tasks 5, Tasks 10, and Task Random, which were essentially for running 5 tasks, 10 tasks, or random number in different places in my experiment. And you can see how that's not a composable way at all for doing it. All right, how would this code then look in Congame? This is the full 1 hash lang line, for the record is, missing for the study in Congame. And this is all in one file. What we do in order to share the variables is we define def var at the top, not the usual define. Def var is a variable that gets stored and persisted to the database, which is why you see these set bangs here. The set bang is literally store this variable on the database, which is what it's doing here. So now I don't have to think about the database. I don't have to do a whole lot of things. Moreover, these variables are local to this file. I can export this study in some other file and reuse it without worrying that someone else has called a variable toss or guess. They're not going to interfere with each other. And then if I now wanted to repeat these studies twice, so I defined down here, I don't know if you can read it, def study coin toss. I can now repeat this study by simply saying coin toss 1 is the first step. Well, what do I do for the first step? Well, I run the study coin toss. And then I want to run coin toss 2, which is what? Again, coin toss. These 2 studies will run. That's all I had to do. No copy pasting and so on and so forth. There's other ways you could do the same thing. Obviously, this dumb code, because you literally just want to repeat it twice. There's other ways of repeating literally the same thing twice. It's just to highlight that this is very straightforward to reuse. All right, so let me compare then just what the benefit is of Congame here and where I think it comes from. So I think fundamentally the difference in O3 and Congame comes from the fact that we have a better notion of what a study is, and we use the better data structure. Secondly, I could use the full power of record anywhere. What I mean by this is, going back to the example, I can everywhere before which I should have said, so def step does a bunch of computations first, and then MD stands for Markdown. This is the Markdown page that will be shown. So that means that in this form, I can generate dynamically. I can use Racket to create some part there or to compute it. I can do computations before, and so on and so forth. I don't have to think about where am I? Do I have the full power of Racket available to me? If we go to the O3 example, I cannot use Python code to generate a page. This down here is template code. It is, what's it called? Ginger, I think. So you have some of Python, but not all of Python. Up here, yes, you have Python code in some sense fully, but you cannot really create a study and pass it around. A study is not even an object that can be created. It's literally configured across multiple files. And so these 2 benefits of having the full power of Racket everywhere and having an arbitrary data structure based on what we find useful, they are immediately allowed by continuations because they can close over arbitrary Racket code. So we never had to think about it, never had to worry about it. Now you might say, okay, but I could have gotten that without continuations. True, but continuations enabled it without us even having to think about that. So that's really the big feature. All right, so these are the benefits that we got from it, and this is why we were building it and what we tried to get. And with that, I'm handing over to Bogdan to talk about how this all works.
Okay, so like Mark said, we've talked about the why, and I'm going to talk a little bit about how this stuff works. And to begin with, I'm going to start with what, sort of how you might use continuations on the web in the first place. And to do that, I'm going to start with an example to try and illustrate. I'm sorry, this is going to be quite code heavy going forward, so I hope I don't bore you all too much. But basically, this is some piece of code that implements a number guessing game using regular web programming techniques. And so how we normally do that is we have two separate pages, one for picking the target number and showing a form to the user. And so it does just that. It picks a random number, it stores the number in the user session, and renders a form that lets them make a guess and points at the other page, which is where we then, once they submit the form, we look up the number off their session. We do a little bit of validation because now this is a named page, so they might have landed here in some other fashion. Then we take out the guess from their form, and then we compute a response, or we compute what we think their guess was. Instead of this, in a language with continuations, what we can write is something more like this, where we have one page. As before, we pick a random number between 1 and 100, and then we do something interesting, which is we capture a continuation and map it to a URL, respond with the form, and suspend our request handler. So we send the user a form that contains a URL that, when visited, will resume from the continuation of the send suspend call and return a new request representing the user's form submission. Okay, and then as before, we take the guess out of the request and we compute the result. And so the thing to note about this is, one, we no longer need the sort of side channel where to store that target number, right? We simply use, as Marc said, the full power of Racket. We just use lexical scope. We are effectively in the same function. We have a reference to n, and so we just use it. And then also, I would argue that the control flow itself is simplified, right? We just come into the page, we send a response back, we wait for them to come back to us, and then we continue and do our thing. Does that kind of make sense to everybody? Great.
This is what I meant when I said direct style. So this is what that looked like.
Okay. And then with that in mind, let's think about how we might implement a mini version of Congame. And so to reiterate, the core of Congame is studies that are represented as trees of steps, which are simply functions that generate HTML, and other sub-studies. And then on top of that, we have a servlet that traverses a study object, and this is what we implement using continuations. And additionally, we have these things that we call widgets, and they are what let a participant interact with the study. And you'll see what I mean in a second. And this is a full implementation. This is everything you need in a language that gives you continuations to implement this mini version of Congame. And so what we have here is a struct for steps, which contain one field, the handler. The handler is just a procedure that generates some HTML. Then we have the study, which has one field, list of steps or other studies. And we have our procedure for running a study, takes a study, and then iterates through all the steps in sequence. Its base case returns continue because these calls to run study can be nested within each other. And then if there is a step to run, it calls run step with that step. Run step checks if the step is itself a study, and then just trampolines back to the top to run study. And if it is an actual step, we use this send suspend dispatch function, which gives us a function that will, when called, when applied, will map our continuation, the continuation of send suspend dispatch to a URL. And so we simply call the step handler to produce the HTML and suspend at this point. And then widgets look a bit like this. We could have a button widget or a form widget. A button just generates an anchor with a label and a target URL that uses that embed function that we got from send suspend dispatch to map this function to a URL. And then when this function returns continue, we end up returning continue from to the continuation of the send suspend dispatch call. We end up returning from run step, and then we end up matching on the value. In this case, it's going to be continue, so we're just going to move on to the next step, right? And so this looks no different than any sort of tree traversal code that you might write. And then putting it all together, you might have, you know, a little study that doesn't do much, but it renders, you know, a page with a paragraph that says, welcome to the study, uses a button widget to let the user continue on to the next step. And then the next step, in this case, is just done, and it says, thank you for participating. And then we put these together inside a study and use our run study function inside a web request handler to actually run it for a participant to actually go through the study. And yeah, I say this is a mini Congame, but really our full implementation, it just has more features, but fundamentally it works the same way. And so next I'm going to talk a little bit about some of the challenges we encountered in using continuations to build our system. And one of them was using dynamic variables with continuation. So dynamically scoped variables, I should say. So Racket has support for dynamic variables via its parameters functionality. And parameters are thread-specific and continuation-specific values. New threads inherit the parameterizations of their parent threads, and in Congame, where we use them is to store the participant's current position within a study. And so Marc spoke about how we store data in the database. And so we use this position to determine where exactly the data should be put in the database. And just a little bit more about how parameters work for those who don't know. Parameters are created using make parameters. So here I'm defining a parameter called current directory whose initial value is false. They can be changed using the parameterized form. So here I'm using parameterized to change the value of current directory to /home/Bogdan for the dynamic extent of its body. And so when I call display line current directory, it will print /home/Bogdan. Or they can be changed using direct assignment. And so if you call a parameter procedure with one argument, that changes the value of the parameter. But direct assignment mutates only thread local state without affecting any surrounding parameterizations. And this becomes relevant in our next example, where we define a current position parameter whose initial value is null. We parameterize the current position to root to the list root study-1, launch a new thread, display the current position, then directly assign a new position, and then display that. And then separately, we have another thread that just displays the current position. And when we run this code, what we get is some ordering of these outputs, where thread 1 always prints list root study-1, followed by list root study-1, study-2, and then the second thread always prints the empty list because it's unaffected by either the parameterization or by the direct assignment that I've done here. And that can, when you combine threads, parameters, and continuations, and I'm sorry about this example, it's as minimal as it gets, but it's extracted from our system. You can have this kind of parameter loss issue, where here I have a parameter, p, whose initial value is false. I launch a thread, install a continuation prompt, then parameterize p to p1, then inside the parameterization, install p2 as the value of p, and then capture the continuation up to that prompt. Okay, and I send that continuation over to this other thread, which restores it, and then within that continuation prints the value of p. And so what you might expect just looking at this code is for the output to be p2, but actually it's p1, and it's because of what I just said. It's when this direct assignment happens, it's only modifying some state that's local to this thread. So even though it's something that happens within the dynamic extent of this continuation capture, it's not something that survives sort of the capture. Okay, and this was an issue for us because we were trying initially to track the position using direct assignment. Obviously that didn't work, and this was the cause. And the second issue that can happen when you combine all of these things is kind of the reverse of this problem. So here I have an example where I have two parameters, A and B. They both have an initial value of false. And when I parameterize A to the symbol A, install a prompt, capture the continuation up to that prompt immediately, and then restore it and print the values of A and B, I get what I expect, which is just the initial values, right? So F and false and false, because I only captured the continuation up to this prompt, so I expect it to be unaffected by the parameterization. However, if I very slightly modify this code to add a second parameterization within the captured sort of chunk of frames, then what happens is quite surprising, and the output is A and B. And so you can have this kind of parameter revival issue, at least with Racket's implementation of parameters and of these features. And this happens because for performance reasons, the parameterized form ends up extending the previous parameterization that is visible to it. And I don't remember the full details, but it mostly has to do with making the frames smaller and lookups faster. Okay, and with that, I would like to reflect a little bit on our use of continuations to build this system. And I think the main benefit has been that continuations let us implement our study harness, like the core of our system, as just a straightforward depth-first traversal tree, which we probably would not have been able to do. Or I know we couldn't have done it with just regular web programming techniques or with like a weaker form of continuations on the web that you see in some languages where you map a closure to random URLs, because that would not have given us the control flow benefits. It may be possible to implement a system like ours using a slightly less powerful language feature such as coroutines. If you don't need the ability for the user to use the back button and take a separate path through a study, which for Congame we don't want, then coroutines might be enough to get sort of similar benefits. But if that is a desirable property, then you would, I think, need multi-shot continuations. And the issues we encountered in building the system were mostly due to these surprising interactions between parameters and continuations. If we were to do it again, we would probably just avoid using parameters and pass like a context object between steps of a study and just avoid this problem altogether. Or, I mean, at this point, we know what the paper cuts are, and so, you know, we know how to avoid them, but yes. And finally, I would say also the mental, continuations can have extra mental overhead when you're programming with them, or at least when we program with them, because we don't use them very often. And debugging issues with continuations tends to be quite hairy, and so it would be nice if languages gave us more tools in order to be able to inspect continuations at runtime. So I'm thinking about source locations or which objects are keeping references to these continuations when debugging memory issues and so on. Marc, if you want to add anything.
Yeah, and so just one thing to finish off that I feel after all those years working on it quite strongly is a lot of discussions in computer science often read like, oh, but I could have done this with X, or I could, you know, and the extreme version of that is you could have written this in Fortran, which is true because the principle is powerful. Right? But as an economist to me, it's like, okay, but what's the cost? Like, what's really the cost? And I think the one thing that I would also take away from this is like continuations were fundamentally the right tool for what we were doing, because what's going on is that what you try to do is you get to a certain point in your downside, the costs were all these bad interactions with parameters, which were difficult. And Bogdan mentioned the mental overhead. We have this one, I think this is like literally the worst bug, I mean, worst in terms of characters per hour spent. We spent probably as many hours as we had characters at the end to solve it, because all we had to do is, I think, add /delimited, or I can't remember which one is like, what it is like delimited continuations. I can't remember.
We were using composable continuations when we only needed delimited.
Yeah, so we had to delete the composable, and after 5 hours of running around and trying to figure out where the bug came from, is this what's going on? Deleted the composable, ran it again, bug was gone. Back then we didn't quite understand what, I think like Bogdan kind of understood, I definitely didn't understand what was going on. Nowadays I'm at the stage where I was back then, and he understands what's going on. But the point is continuations are quite hairy in a way that other things are. And so that's definitely a downside to keep in mind. Notice, however, that the continuations are entirely hidden from the users. So that once the core is done, again, you don't have to think about it. It's really not something that's passed on to the user. So just the final thing, I think where this, therefore, if you have in a situation, I think the part where continuations can be useful is whenever you have some process where you want to delegate out some work to another process that fundamentally you are not right now coding. It could be a machine, it could be a participant, a human, it doesn't matter. You want to shout it out to some, AI model that you've trained or whatever, and then once it comes back, you continue. If you have that kind of situation, I think continuations are fundamentally the right tool to use. The right kind of continuation, so you might have to play around with that, to use, because it is literally the abstraction that you want.
Thank you very much.
So when you capture a continuation and you're sticking it in you stuck it in a URL occasionally, is that right?
Yeah.
There's a problem that occurs there, which is you can end up with a very big URL if you have a very big continuation. Were you just careful to make sure that you didn't have large continuations?
No. So we don't stick the full continuation. We don't serialize the continuation.
Oh, you're not serializing it?
No. We just keep it in a hash. This is what the web server does for us. We keep it in a hash. We generate a URL and then,
Oh, yeah.
URL, and they come back to us, and then we resume from the hash.
No, okay.
That's also why, like, the full hour, you don't have to think about it.
Right. So we can close over things such as a database handle, and it will continue working just fine. Whereas if we were serializing full continuation of the URL, we obviously couldn't do that.
Yeah, no. Okay, that version makes sense. I have a different question. Do you know what effect handlers are?
Vaguely, yes.
No.
They're the right way to program with continuations.
I know.
They give you a bit more structure. You get exactly the same. You won't get any different expressive power, but it's a bit easier to isolate what the hell's going on.
You get more expressive power with continuations, right? Because you can use continuations.
No, you couldn't. They're equally expressive. But I'm not sure what current support in Racket is like for effect handlers. We built a library to do it a number of years ago, but it wasn't used in anger. But it might be an interesting follow-up. Absolutely, yeah. I mean, there are languages like OCaml only have single shot, but it basically lets you do the same kind of things, but you isolate the weird control functionality behind an interface so that it's all contained in one place. And you can also compose different functionalities together. If you're just doing one application, though, maybe you're fine, and particularly if you're in a language like Racket. Yeah.
Anyone else? So if I can follow up to that, so yes, right? But the Racket web framework predates pretty much the popularization of effects and effect handlers. the problem is parameters, right? So if you did those via effects, you would get similar problems. And that's because parameters predate threads, right, in sort of scheme history. And the problems of that have been known for a very long time. So we did, I think we did a paper about 20 years ago. But, so I'm very gratified to see that in your paper because we kind of argued this on sort of principle, right, that it's, so parameters are this fundamentally unmodular construct that conflates like three things, right? You have like assignment, bad per se, right? You have this sort of dynamic binding thing where you want to associate, really what this is about is associating a bunch of data with a continuation. And then there's this inheritance thing that gets passed from one thread to the next. And then kind of, it used to be like it's essentially just a mutable variable, right, before threads, but then through because the introduction of threads, they had to become thread local, which adds another dimension of unmodularity to the whole thing, so we get this current mess. So, but I remember that at the time we were widely, everybody said, well, but it's the practical construct. It's the one that you want, right? And we were like, it's going to cause problems because of the unmodularity, but we never really made the case based on real-world examples, and you did. So that's wonderful.
I like how you said, this was widely known because when we posted this PR, question of what's going on rapid, Ryan Kaufman, I can't remember, it is known. It feels like Game of Thrones. It is known. So
Yeah.
Okay,
Yeah.
To be fair to Ryan, he said this is known but not widely.
Yeah.
Well, depends on. Widely known within the scheme, so widely known in a very narrow community. So, of course, I don't think parameters in that particular shape exist anywhere else. Would be surprised. All right. Anyone else? Then thank you again.